Okay, welcome back. In this video and series of videos, in fact, we're going to be creating a procedural wood texture. So let's just dive right in and go directly into the shading workspace, change over to cycles and turn off scene world, and we'll decrease that opacity so the background doesn't distract us too much. Next, let's just take this cube and I'm just going to scale this up in the Z-axis, but I want to make sure I do that in edit mode so we don't have any issues. So we just scale that up in Z-axis and create a nice big post. So this is essentially going to be our big chunk of wood. I'll go to object mode. I'll squeeze this down a little bit. And we'll just move this out of the way. Now the next thing I want to do is just look at some reference. So I've just brought up wood here in Google. And what you can see is a number of different types of grain, all different, lots of different colours, lots of different textures on these different bits of wood. And the one image I want to show you is this one here. So this one here shows you why we get the wood grain. We have these age rings on our, in this case it's just a log, and we've cut down this and you can see that we have different grains running down it. Now if we cut pretty much parallel or as parallel as possible to the actual rings, we get this nice interesting grain that very similar to something that we have here. And if we cut directly across these, we get a much thinner, tighter grain. That's more like what we would have on this type of wood. So just by creating an object that has these rings on it, we can actually cut or move our object in different ways. So our vectors change and we get different grain patterns. And that's going to be really key to creating a procedural wood generation tool that gives you near infinite different variations of wood. So let's close that down. And first of all, I want to show you the way I used to make wood. And I used to make it using the wave texture. I would set this up to rings. Let's have a look at the result. And then I would use my texture coordinates to manipulate the actual rings so that they were on the right place on our object. Now you can see the middle of the rings is in this top corner, but if I change over to object mapping, this will actually appear in the middle. That makes things a lot easier. Now, as far as this gradient goes, that's the sine gradient. I'm going to use saw instead, which gives me much more interesting rings. And then I would change things like the distortion and the distortion scale. I could tweak things like the scale in here, as well as a few different bits and pieces, the rotation and things like that to try and get an interesting wood result. And along with using things like UV distortion, this was actually pretty good for creating a nice wood texture. But the wave texture itself is a little bit limiting. But instead of that, I'm going to create the entire system from scratch, just using vector math and some math nodes. So I'm going to get rid of this mapping node and this wave texture node. And first of all, what we want to do is we want to grab a vector math node, and just like we were doing with that ring texture or the wave texture set to rings, we want to essentially just be looking down on our object and creating concentric rings. We don't want to worry about this Z depth of our object. So for the moment, we'll take this object mapping, we'll plug it into the vector and we'll go to multiply and have a look at the result. You can see nothing is in there because we have 0, 0 everywhere. We'll take these first two to 1. And now you can see that we have some nice mapping on this object, but we don't have any depth in Z at all. We don't have any gradient going up and down. So we're only really working on this top gradient. Now, right in the middle here, on our texture coordinates, we have 0, 0. And as we go further out, we get a higher value. What we'd like to do is we'd like to take these values and use them to create a gradient. And luckily, we have a tool that allows us to do that. We can use another vector math node, and we can choose length. So this is essentially going to give us a value with the length from the center of that 0, 0 axis out to the edges. And as we get further out, this value goes even higher. So now that we have a length in there, or a value that is essentially a gradient, we can use some more math to turn this into concentric lines. So the way that we're going to do this is with another math node. We'll take this and we're going to change this over to fraction. So at the moment, what fraction is doing is it's taken what was originally our length, which was 0, out to about 1, around about here. And then from 1 up to probably about 1.2, around about here. And it's taking each of those 1 unit measurements and just creating a new gradient. So at the moment we only have 1 ring, because right on this edge here we have a value of 1. But if we take this value and we multiply it so that this edge, instead of being a value of 1 as it goes into fraction, is a value of 10, we should get 10 rings in this area. So let's go to math, plug this in and choose multiply and just plug in 10. And now we have 10 rings. So this multiply node is essentially just become our control for our number of rings. And that's incredibly convenient because we will need that later on. So with our rings created, we have this kind of grain running down our object. Now at the moment that's not very interesting. The way that we're going to make that more interesting is by distorting it. So we've done vector distortion before. In this case we have to do things a little bit different than before, because in some cases we're going to want to discard that z depth, and in other cases we want to keep it, so we can't just use our vector distortion that we used before, or our UV distortion. We're going to create this all from scratch. So what I'm going to do is take this texture coordinate node, put it over here, and we're going to create a noise texture. Grab this, we'll create a redirect here and plug in our vector. Next, what I want to do is take this value that's coming out of color and I want to adjust it slightly. And the way I'm going to do that is using a vector math node. Now this might seem a little bit strange because I'm taking a color and I'm using a vector math on it. But if we think about it, the color is just 3 values and vectors are just 3 values. So color and vector do work together quite well. Now I'm going to subtract from this and I'm just going to take off about 0.5 from each of these values. And you can see that this map gets a lot darker. Now the next thing I want to do is just control how much of this is actually added into our distortion of the rings. And the way we're going to do that is, instead of using mixed color node with linear and using the factor, we're actually just going to use a scale node. So again, it's a vector math node, and we're just going to change this over to scale. And now we have a value here that's going to change the value that's coming out of this. And now we just want to join this back in. So what we could do is we could just add this back in at the moment. So let's grab vector math node, set this to add. I'll put this in the bottom slot and we'll plug this in here. So we'll just grab this, plug this in. I'm going to plug this into this multiply node. And now this is our result. Let's have a look through our fraction. And you can see our distortion is far too high. So let's take this scale down. Now, if you look at the center of this, you can see it moving from side to side in here. We don't want that. Now, this is a problem that we usually solve by using linear light in our mix node. But since we're not using that, we're going to have to figure out a different way to do that. And luckily for us, the way to do that is pretty easy. We are going to grab a vector math. I'm going to change this to normalize. We'll take this output here at the moment, which we might have to adjust in just a second. And then we're going to multiply it back in. So I'm just going to duplicate this add node, plug it in here, and we're going to multiply this, and I'm just going to plug this in here. And if we increase this scale, you can see that now the center stays exactly where it is, but we're just affecting this. Now, if we look at the side of our object, you can see that we are also affecting the Z of this. And at this point, we don't want to affect the Z of this. So the way we did this before was we multiplied by 1, 1, and 0. We're going to do the same here. We'll duplicate this over. We'll just put it before normalize. And now this should fix this issue. So let's go up here and let's scale this down. Okay, and we're definitely getting less of that effect on the sides. Let's mute that node to see the difference. So definitely a difference in that node. Okay, so now that we have mostly fixed this, we do want to actually add in controls so that we can stretch our noise texture on the Z-axis. So the way I'm going to do that is, let's just take these nodes and put them a little bit further up and make a little bit of space. I'm going to grab a combine XYZ node, And here we're going to have our values for X and Y. And I'm just going to take these to 1 just now. And I'm going to grab another multiply node. So we'll just grab this one, plug it in here, plug this in here. Now with this at 0, we're not getting any effect on the z-axis, but as I increase this a little bit, we can actually stretch this noise texture on the z-axis. So let's take it down to about something like 0.3, and we're getting a nice result. Let's actually affect our scale a little bit more. Let's increase this a little bit. Okay, and what I see is a few little issues here. So we're getting a lot of an effect on this, and really what we'd rather have is pretty much no effect right in the middle and more distortion as we go further out. Luckily, we already have a way to do that. So we already have access to that length node. So let's take that and let's use this map here. Now the reason I'm using this map is, again, if you remember back over here, we took this length out from a map that has 0 z depth, and that gave us that correct gradient. If we muted this node, you can see that that gradient actually appears on the side of the object and not on the top. Because if you think about it, the center of this object, the very, very center, where this origin is, that's where we're going to get the value of 0. And as we get closer to the outside, we're going to get higher values. But if we're ignoring the z depth, the value of 0 is directly down the center of the object. So if we want to use a length over here, we have to fix these nodes. Once again, we have to make sure we take away the z depth. And we're not using multiply here, we are using length. So again, we have this same effect here. Now what we have here is we have a value of 0 in the middle and a higher value on the outside. And if we plug this into our scale and we look at our final result, you can see that we have less distortion in the middle and a lot more as we go out, but our values are a little bit off here. So what we'll just use is a map range node just to control these values. So we want to take this to max and just reduce this. So we want a little bit of distortion on the outside, but not too much. Let's try something like 0.17, and now this is going to work a little bit better. We kind of have our grain on the outside as well, but again, we can adjust this z depth to adjust this the way we want. Maybe about 2.7 is fine for the moment. And also we have controls for our number of rings. So the more rings we have, the more detailed that's going to be. And what we'd like to do is layer this noise over and over. So we've layered noise several different times in the past. What we're going to do in this case is we're going to take all this information here and we're going to turn it into a single node group, and we're just going to duplicate that across our model. Okay, so it's challenge time. Your challenge in this video is to turn part of this node tree into a single vector distortion node group. Now we're only going to be using this node group on this one particular material, so there's no need to turn it into an asset for your asset browser, but having it as a node group means that we can easily duplicate it and layer a number of different distortions on our rings. Make sure that you have controls for the X and Y distortion amount, as well as a separate Z amount and scale. And feel free to add any other settings that you think will be useful. Now in the next video, we're going to be duplicating a couple of these distortion node groups to add more variation to our rings. And we're also going to be looking at changing the look of the gradient in the rings, as well as adjust and vary the size and width of these rings. I'll see you then.